Hello everyone, welcome to eTech Facebook Live Fridays. I'm Tech Bob, and today we are going to be going through the iPad charging port replacement. Hopefully you are catching us live right now. I think I sent the event up at 2, so it's a little bit earlier than 2. It is 12 o'clock, so apologies on my side. But just to speak to this repair before we actually get started with it, this is one of the more common board level repairs, and it's on the entry level side when it comes to micro soldering. So if you are curious about doing micro soldering, or you've had a lot of customers you've had to turn away because you don't know how to do this, this is a great one to start off with. As far as skill set needed, it's an easy way to get comfortable with a microscope, with solder. Definitely on the easier side when it comes to like the TriStar we showed a couple streams ago. So this one is a good one to get started with. Before we actually remove the port, we're going to go over kind of the same things we did with the TriStar tester. What Hector has in front of him right now is the board. So you do have to remove the board to do the charging port. And he specifically has an iPad 6 board here. The cool thing is pretty much any iPad you repair that has a soldered charging port is going to be about the same. Sometimes the pads are soldered on top, sometimes it's on bottom, it varies, but the general process is the same. So for testing, we have a couple tools we can use. The first one that Hector has is a USB ammeter. What this does is basically tell you how much current the board is pulling. If you plug this into the ammeter and it's showing nothing, or it's showing a sporadic number, like it jumps up real fast, jumps down, it could also be a TriStar issue, but typically it's going to be a charging thing if it doesn't show anything at all. Now Hector has two things there. The little thing that has a screen on it, actually before the TriStar tester, that other thing, that's a USB ammeter, and then that's plugged into a 6-port charger. That one is a product we sell as well. It has, I believe, 5 or 6 readouts, so you can use that as well if you're doing multiple devices. But that is definitely the lower cost side for testing the charging port. The TriStar tester Hector has right here, we showed this again on the TriStar stream a couple weeks ago. This one is a little bit more in depth, so this one's a little bit higher cost. What this one will do is it'll run the test, and just like with the TriStar, it'll test every single pin going through the port. If it detects an issue with a certain pin, it'll tell you what's wrong with it. So he's running the test, and this one should pop up as a dock connector. I think it says bad port, something along those lines. But the cool thing with this one is it'll help pinpoint if it is TriStar, if it is dock connector. Typically, if it's an ambiguous reading where you don't know for sure if it's one or the other, we recommend doing the charging port first, since it's the easier repair to do, and then do the TriStar from there if that does not fix it. So that's just the testing side of it. We're going to disconnect the TriStar tester and continue on with the removal. So the first thing we need to do for the removal of the port is on the back side, we have the tape that covers the charging port soldered pad. So Hector's going to flip it over and show under the microscope where that is. There we go, right there. So Apple likes to cover anything that has solder points or pads with tape. So he's going to remove that tape carefully, and there you go. You have your exposed solder pad. So in theory, what we're doing here is we're desoldering every single one of those pads. Hector, how many pads is this? Like 25 or 30?
Around.
We won't count them live, but it's a good amount. Shift the board to the left, little Hector. There we go. Cool. A little bit higher. Good. Cool. We're just trying to align things on the cameras. But so you hear all the pads that we have, and the goal when doing this is to separate every single pad on the port from the pads on the board without damaging the pads on the board. If you damage this old port, it's not a big deal because you're replacing it, and the new part, I mean, it's a sub $5 part. So if you damage the old one and just testing things, you can put a new one on. It's not a big deal. What you don't want to do is rip the pads on the board. So to do this, there's a couple safety things that we recommend, and we train this process as well. I think I already sort of spoke to this, but we go over all these safety things to make sure you prevent damage to the board and also technically yourself, so you don't burn yourself or hurt yourself when doing the repair. But for this right here, the first thing we do is we apply flux to the pads. As we mentioned on the TriStar video, flux helps melt solder, or it helps lower the temperature of solder slightly, just because it seals where you're soldering. It doesn't let oxygen in, which speeds up oxidation and then causes those cold solder joints. So he's going to apply a little bit of flux over the pads. And the question we usually get here, and it comes up with any repair, micro soldering repair, how much flux do I add? The general answer is just make sure it's covering what you're desoldering. Definitely start with less and work your way up as needed. You don't want to flood the board, but putting on too much flux really won't cause any issues besides more cleanup needed. So once he's got that on there, the next thing we're going to do, so this is where the process can kind of vary depending on where you've learned this or how you're doing it yourself. So we recommend using a solder alloy. I believe this brand is Chip Quick, if I'm not mistaken. What solder alloys do is when you mix them into solder joints, it helps lower the melting temperature of that joint, so you don't have to use as much heat. So what Hector's going to do is take his soldering iron and he's going to touch that. It looks like solder, but it's not. It's solder alloy. So he's going to touch that to every single pad, mixing that into the joints, because what that'll do is now when we begin the removal process, it'll require less heat to remove it. And you can tell where it's being applied. You see how it was just a like gold color on the pad before. Everywhere he's added this alloy, it's going to be a silver color and it'll look shiny. And you can pretty much tell, so I mentioned that it has a lower melting temperature. Almost as soon as he touches that alloy stick or the pads that have the alloy, it almost instantly melts. So that's the whole purpose of it. And it looks like he's pretty much got all of those done. And same thing here as far as how much. We I think use like less than a centimeter of this stuff for every charging port we do. I think we purchased a 4.5 foot section of this. It's sold by the foot, but that'll last us a good like 6 months to a year depending on how many charging ports we're doing. But again, this one, the alloy just makes the process easier. You can do this process with just solder, so just swap out the alloy you use for solder, but this does make it easier and quicker to remove. Now, if you get any solder bridges here, which a solder bridge is where you join two pads that are next to each other that aren't supposed to be. So I don't think Hector has any right now. Looks pretty good, but that's not so important right now as when we remove it and put the new one on. That's when you don't want bridges because that'll cause issues. So now that Hector's got that in there, we're going to start removing the port. So the thing with the charging ports, Apple does like to put adhesive around the edges of the charging port. So when you start pulling it up, you're going to feel a little bit of resistance, but once you get that edge separated, it's all easier to remove from there. So Hector, if you want to start removing it. I think right now he's just touching up the pads to make sure it's really mixed in there, because what can happen when you mix in new solder or the alloy is it can just be a top level mix. Right now he's making sure it really feeds into the joint, so it's not just on top, it's in the joint underneath that too. I don't think I see any questions popping up on here, but if you guys do have any questions as far as the process, let us know. We'd be more than happy to answer. Because like I said, this one, if you're looking to get into micro soldering, as many people are right now, just because it's another a revenue stream for your repair shop, if you are on the slower side with other repairs right now, this is a great one to get started with. Alright, so what Hector's going to do, he has the tweezers in his right hand, and he's kind of just cleaning up around. So that's some of the adhesive that we're dealing with. And the cleanup just helps with removing the port. Oh, did you already take it out?
Yeah.
Oh, sorry. I was talking while he did that. You saw the process happen. I'll just speak to what happened. It came off pretty quickly. I thought he was still removing. I saw adhesive underneath it. So he heated it while he lifted up on it. It came off very easy because he did use that solder alloy. Like I said, you blink and it's done. When you use solder, it's a little bit slower, but that process, you can still see every single pad on the board has solder on it. So no damage to the pads there. Now, I'll briefly talk into what happens if you damage a pad. So ideally that doesn't happen, but if it does, not all of these pads are 100% vital. There's multiple pads here that are considered ground pads, which what they do is ground the board, so in case there's a short or any type of static. Now, there's multiple pads, so as long as you have at least one or a couple ground pads, you're okay. Obviously, you don't want to rip pads and then complete the charging port like that, but if it happens, not the end of the world. Now, how to figure out what's ground versus not ground, you can actually test it with a multimeter, or you can use schematic software like ZXW, where on the schematic it'll tell you which pad is which. You can actually look at the schematic and then compare it to where you damaged the pad, and if it comes up as ground, you're okay. Now, if it comes up as a data pad or a pad that's actually tied to some other component, you do have to rebuild that pad with a jumper, just copper wire. We're not doing that today, a little bit higher level of a repair, but if you do it, take your time, don't rush, and you're careful with the removal. There's usually less damage that happens on the install versus taking the port off. So if you've gotten this far and it looks like this, you're good to go. Now what Hector just did is he put more flux on there and he's going to clean up the pads. The reason this is an important step I don't know if you can see on the camera, but it's kind of all uneven right now. You have some pads that have more solder than others, and others that have less. If you don't clean this up and try to put the new port on there, the problem is you're going to get a lopsided solder joint. So on one side it may be good, but on the other side it most likely won't. And the way he did that, he just took that desoldering braid and the tip of his iron, heats it up, the copper on the braid sucks up that solder, which makes it pretty easy to clean up. And then he just took some alcohol and a cotton swab, or Q-tip, and he cleaned it off. So that looks very clean. If you can get it like this on your first go, you're doing great. Now, Hector's been doing this for many, many years, so if he makes it look easy, that's why. So if yours doesn't look as clean, that's okay. The main goal in starting out doing this is that it works after. You can kind of perfect your cleanup and the what's the best way to put it? The look of your joints, but as long as it's a solid joint where it's not going to separate, you're good to go. So what he did now is he applied some flux because it's time to now apply solder. Now, this is where we do recommend using solder versus alloy, and the reason for that is alloy typically is a little bit more brittle, so it's better to use alloy on things like ICs where it's not going to be it's not going to have tension or force on it. Now a charging port, because this flex cable kind of feeds to the bottom of the device, if someone is rough enough and this flexes or say it moves at all, the joints can crack, and if it cracks then you're not going to get a charging port that works. So we are using solder here to rebuild all the pads. And now speaking, Hector, can you bridge something just to show it? There we go. So he's trying on the bottom left corner. He had one, but he's good at taking the bridges away, so he's trying to do it right now. But basically, if you get a solder bridge, the easiest way to get rid of that is apply a little bit more flux, and then you run the iron parallel to the pad, so basically between them, and that kind of helps split it up. Solder will naturally want to flow to the path of least resistance, so that's wherever it has other metal that can move it to. Technically, it's a pad. And again, he's doing a pretty good job of keeping no bridges. Now, bridges usually come from having way too much solder on the board, so if that's the case and you can't just separate it using the iron, running it parallel between the pads, what you can do is use that desoldering braid and remove some of that solder. And again, what he's working for here is just an even layer on all of those pads, just to make sure that when our new port goes on, there's not going to be any issues. And he's cleaning up again here. And you'll notice the cleanup is kind of a repetitive process. It's not always required in between steps. Like, you had that flux on there already. If you're going to put the port on, you can technically reuse that flux, but Hector's pretty methodical on this, and you'll notice that with people who have been soldering longer, cleanup is definitely on the better side. And again, it's a practice thing. So he had cleaned off the old flux that was already technically used since he had heat to it. He applied a new layer of flux. Now, when it comes to the new port, the most important thing before we solder it on is aligning it correctly. Now, if you notice on the two ends of those solder lines, there's little windows. So you can see it more on the flex, but you see how there's a little opening in the top left row and then an opening kind of on the bottom right row. You see that little square he put in there? So that's your alignment guide. Now, it's very important that you align that far right and far left one, because if you just do one side, the problem is you're going to end up soldering it on crooked. What he's doing now is applying flux to the top side. What that'll do is kind of help everything seep together. I've had people that have pre-tinned the port too, so they'll put solder on the flex before laying it down. It's kind of an extra step that's not needed. As long as you got a good amount of solder, you have a little solder, it's the best way to put it, I guess a mound, a little bit of a hill. You don't want to have a solder mount because that's not good, but just a little bit so that solder just easily goes through. So Hector's holding it down with his tweezers on his left hand, and then he's using the iron with his right hand to help melt that pad down, or melt the solder to where it comes up through the pad on the flex. And this is mainly to tack it on so it doesn't move around. And he'll do this side, and then he'll do the other side just to make sure it's tacked down too. And then that's where you run through making sure every single pad is soldered down. So he's just working on that side. And I will say, as far as the soldering tips go, when you're doing a charging port, something on the bigger side is better. So Hector's using the blade tip right now. There's it's like a chisel tip is another one that's pretty good for this. You definitely don't want to use like a very fine pointed tip for this because you don't get as good a heat transfer. And because you don't get as good a heat transfer, it takes a lot longer to get those joints to melt. And Hector, so what he did right now, I don't know if you could see it on camera, he cleaned the tip of his iron. If you're having an issue with heat transfer, you can use it's like a metal, it looks like a scour pad basically. That'll help clean the tip of your iron because what happens is anything that oxidizes on the tip of your iron will prevent heat transfer. And if you have that issue, it's not going to melt the solder as easily. And what Hector just did is he touched a little bit of solder to the tip of the iron. That's going to help flow it down in there. There we go. And he's got that pad tacked down. You can see a little bit here. It's a little bit shifted. There we go. So this is very important because it was aligned on the other end. This is so long that it can be aligned on one end, not the other. So you want to make sure you get both. And putting downward pressure or slight downward pressure on the flex is important because it makes sure that the flex is sitting down and the solder is coming up. If you don't put downward pressure and just touch the iron to that pad, the problem is the solder may come up slightly, but it's not fully seating down into the board, which is important. And I don't think I see any questions that have popped up. And the cool thing too, so I mentioned that the soldering process for replacing an iPad charging port is very similar. The iPad Air 5 and 6 all actually use the same port. So there is some cross compatibility. So inventory wise, you'd carry literally one part and it covers 3 different iPads. Now on the newer iPads, so like the iPad 7, 8, 9, those also use the same port, but it's separate from the Air 5 and 6. And what Hector just did, I don't know if you heard that sound or could see it on the camera, he upped his heat slightly. So we'll usually use this iron at 380. You can up it a little bit. We typically recommend increments of about 20 at a time, so he upped it up to 400. Same thing when it comes to temperatures. You want to start on the lower side and work your way up. You typically won't damage something from not using as much heat unless you're using like pressure pulling something off and it wasn't ready. But start with low, work your way up. That way you're not damaging something with just heat. There we go, and it looks like that side down. So once you have the 2 edges tacked down, now it's just time to make sure that all of the other pads get tacked down. And this process, it starts off slower when you first begin, but once you get practice with it, I mean, I think our team does these ports from the time the board's removed to putting it back in, it's probably around 5 minutes, maybe somewhere in 5 to 10 on the long side. But it is important to do it right because starting out especially, you may run into a case where you do this whole process, you go and plug the device in to charge it, and it's not working. Most of the time, I would say 9 times out of 10, it's just one of those pads that didn't get soldered down and it's causing that either no charge scenario or a weird thing where it says like accessory not supported. If one of these pads is off, that's an important one, that can happen. Now, while I was speaking, I don't know if you noticed, but Hector, he applied a little bit of solder to the top side. What that helps do is it flows the top side solder down to the solder that you put on the board originally. And what you're looking for, you see how originally it was all gold on those pads? We're trying to turn them all silver. You want to make it look as close to the original as possible. Now, if you mentally rewind back to when we started this, you saw you could barely even see solder on the top side. And that's because usually these things are mass produced. Most manufacturers, when it comes to ports or even components, they don't use excessive is not the right word. In our opinion, an adequate amount of solder, but again, everything costs more, so if they use more solder, it increases the device cost, so that's why they might just do the bare minimum to get it to stick on there. we like to make sure there's a good amount of solder that port's not going to come loose and come back as a warranty. So know how to know if you have enough. You're basically looking for a little slight mound, or if you see that little hole on each of the pads, you want to not be able to see that hole. And you basically just add solder until you get to that point. Again, most of these look like they're going to be okay. There we go. You can see it a little bit better now. See, he has some that aren't filled in there. He's going to run his iron over it. Cool. So that one's done. And so one question we typically get is, do I need a microscope to do this? Now, after doing this long enough, I would say yes. When we first starting out with soldering and charging port repairs, we were freehanding it. The problem with that is you can't see exactly where you're soldering, so it is important to use a microscope. And I would say the microscope is a pretty good investment on the soldering side, because even if you're not doing high-end soldering like ICs or FPCs or backlight repair, if a customer comes in with a device issue and it's not just a straightforward screen or battery, you can look at the device under the microscope and figure out if anything looks off. Most people that get into soldering have seen enough phones by now that you can tell when something is off. If something isn't clean, or it looks like there's residue of something on the board, or components look chipped, those are usually signs of previous repair or something happened to that phone that would cause that. And the microscope is a great tool to do that. You don't have to get the camera to start off with, because that's another investment for the microscope. Those, on average, I would say are in the $400 to $700 range, depending on the quality of camera you get. But the microscope, for sure, great tool to get as far as starting with. The iron is another big one, because obviously you need something to be able to melt the solder. The hot rework station is great too if you're going to get into the charging ports that are a through hole or surface mount. So things like Nintendo Switch charging ports, that's HDMI ports, game console charging port, or game console HDMI ports, laptop like USB ports. That's usually where the hotter rework station is used a little bit more. But the iron for sure is going to be used on really anything you do soldering wise, because it's the precision tool you use to apply solder to each of the pads. Now at this point, it looks like he's gotten most of the pads. He's just going through and cleaning up. And again here, I've seen, in my repair experience, probably over 20 different techs do soldered charging ports, and every single one has a slightly different outcome here. My preferred outcome is that, like I said, it looks like all the pads have an adequate amount of solder. You can't see that hole. If you can, it's not the end of the world, but for the sake of today's stream, we're going to cut it there. That way we don't have to keep applying solder, but they all look pretty good there. There's some where you can see a little bit of a hole there, but the biggest test of this is, I don't know if you noticed, Hector was actually applying slight pressure with the tweezers. You can do that after too, and if you notice there's a lot of play in the port, that means it wasn't soldered all the way. And on the edges you should be fine, but he's going to touch a little bit there on the edge while he pushes down. And that's one thing I noticed really early on. You cannot just use the iron. You have to use something else to press down. When you are pressing down with the tweezers, just be careful not to use too much force, especially if you're using pointed sharp tweezers, because that can stab into the flex. But just carefully run over each of them, put a little bit of downward pressure, and that should get it done. Now let's see, we're a little bit over the 20-minute mark, so we're going to start wrapping it up. Just I appreciate everyone. It looks like we have a good amount of viewers right now, so thanks everyone for tuning in. Hector's still going through it right now, just kind of touching up all those pads. And again, he's done it long enough to where he knows when it's not soldered all right. But as far as testing goes, so right now we have a board that's out. The first thing you can do is actually plug the board into a charging cable right off the bat. Now, it's not going to show the current that you would get when it's actually installed into a board, because it has no battery to feed the current into. But you should get at least, do you know what the reading is, Hector? When you plug the cable in and with just like this, what reading should you get on the ammeter? Is it like 0.2 or something, or point?
Well, the normal is, if it's the iPad, is 2.5
2 point something amps if it's in the device, but outside the device, I believe it's like 0.8 or 0.08, something like that. I'm trying to remember the number off the top of my head, but that's your first test because that's minimal work to test it. What you don't want to do is completely reassemble this iPad, seal it up, then test the port, and then realize it's not working. So it's wasted a lot of time. You got to undo everything again. Now, on additional testing side, so aside from just plugging it into the cable externally, you can also just lay the board into the device and basically put your battery screw on. Minimal installation. You don't have to put everything back together, and just make sure that it works that way. Real quick, Hector, go back to that real quick. This is an important step here that I would say speaks a lot to the quality repair. It doesn't seem like much, but Hector just put that piece of tape back. Why is that piece of tape important? I haven't seen a port ground out against the frame, but you never want exposed solder joints where it's possible to touch metal, which would be the frame. That can cause shorting and all kinds of other issues. So the first option is to put the original tape that was on there. Second option, if say you ripped it taking it off or lost it for some reason, a roll of Kapton tape or Kapton tape can be used. It's just basically heat resistant, ESD safe tape. You can put a little bit on there, but this is a clean charging port repair because you never want to be that repair shop where someone else opens a device that you repaired down the line and they look at it and they're like, man, who did this? You want it to be great quality, so like, okay, someone who knew what they were doing did this, and it wasn't an issue with their workmanship that caused the customer to now have the port replaced again or anything like that. But so Hector, just put that sticker on there, and that actually wraps up the install of the port. Like I said, on the testing side, you can just plug it into a charger at this point. Aside from that, you can drop the board into the frame. You really just need battery, screw, and minimal installation. You can plug your LCD digitizer in, make sure it charges. If the device is still not charging at this point, a couple recommendations here just to kind of top off the stream. First one would be check all your solder points. If any of those are loose, that can easily cause the issue. Second thing would be run it through the TriStar tester again. If it says now that it has a TriStar fault, what was happening before is the dock might have been damaged and it was causing an issue with the reading, but it should read correctly after you do the port unless there's a TriStar issue. So that's what he's doing now, just plugging it in. And I believe this might have been a liquid damage board, so what is it pulling, Hector?
Yeah.
Is it pulling something?
No.
Oh yeah, so
Probably just because the liquid damage.
yeah, so this one is liquid damage, but this, like I said, you want to see about it's either 0.8 or 0.08. I know that's a big difference, but can't remember off the top of my head. And then TriStar tester, same thing, you want to run it through there. But that's it for the actual process. Like I said, if you guys are interested in doing this, let us know. We can do more content on this, or we also offer the training here at our office in Southlake. So you can come by, take the training. It's typically done in a day or less, so about 6 hours-ish. And this is as I mentioned earlier, the course I recommend to someone who's trying to get into microsoldering, and you can have literally zero microsoldering experience. This is the great one for you. And we go more in depth to the process that Hector just showed. He actually trained someone on this 2 days ago, and now that technician is able to do these repairs. So, and again, this is kind of a gateway into all the other micro soldering things that are out there, and it's a good way to get started with it. So that's all we have for today's stream. I thank everyone for tuning in. Let us know if you have any topics you want to see covered in future streams, but we'll probably post our update on what the next stream will be Tuesday or Wednesday next week, so keep an eye out for that. And I hope everyone has a good Memorial Day weekend. Stay safe out there, and we'll see everyone next week's streams. Thanks, guys.